This mini lecture will be about how to screen data or the general process of going from raw data up to data that's reliable and ready to be able to be analyzed. This might be most useful for people who have raw data that they need to turn into reliable data, but I'd like to give an introduction to it for my statistics class as well. So, the basic idea is that when you get data in the world, it is going to come to you in a way that is not ready to be analyzed 99% of the time. So, you could perhaps have done a dissertation or a research group study where you collected data online in something like Qualtrics or SurveyMonkey, and the data is coming to you now from that system and it is not ready to be analyzed and complete. Or maybe you're working in a clinic and you're pulling records and you're writing down people's answers and putting them into a database. Or maybe you're interviewing people or you're doing some kind of questionnaire. So, all kinds of ways in which you might be collecting data from people, but it doesn't arrive to us clean and ready. In fact, you really want to think about data in terms of turning words into numbers, analyzable numbers. So, that's a messy process that needs good thought. And if you are doing real world lab data analysis work, probably about 80% of your work that you actually do, the labor, is in data management, meaning getting through this process to the point at which you're able to actually analyze the data. It doesn't take that long, but getting it ready to be analyzed can take a good bit of effort. So this mini lecture is going to walk through the 8 steps to cleaning up data. First, to obtain the data, then code it, import it into an analysis system like SPSS, examine frequencies for impossible outliers, mistakes, things like that, reverse score or recode items that need it, replace missing items in scales with case-wise means or other methods of estimation, creating total scores for any scales that you have, and then checking your total scores for outliers, skewness, etc. So when you receive your raw data, it will come to you in whatever form that you have collected it or that other people have collected it for you. And it's really important to save that raw data. I can't tell you how many times the raw data has ended up saving people from disaster in a research environment. So make sure that in some way, whether you scan it or if it's perhaps raw data that's come from something like SurveyMonkey or Qualtrics, you just put it away someplace in your computer and save it, because that raw data is assumed to be the most true data. It's the data that came from the participants or the field itself, from the observations that were made. And from here on out, error is possible. So you want to hold on to that raw data and save it. The next thing you need to do with your raw data is take things that are words and turn them all into numbers. Ideas turned into numbers can be complex. You'll want to be thoughtful about how you do that and make sure you're not just kind of willy-nilly coming up with codes. One tip that I have for people who are doing this is sometimes it's actually easier to recode things in the program Excel if your data has come to you as an Excel document, which is often the case, rather than SPSS. Excel has an option called replace and find and replace, where you can turn like everything that's strongly agree throughout the entire data set into a 5, or everything that's an agree into a 4. And you can do that throughout the whole data set. If you convert it to SPSS first, then you'll have to do that process for every single column, right? Separately. You won't be able to do it for the entire thing all at one time. One thing to watch out for, though, is say you have numerous scales you've collected, and in one of them strongly agree is coded as a 7, and in another one strongly agree is coded as a 5, then you have a big problem. You won't be able to do it in Excel. You'll have to put it into something like SPSS and code it there. and turn words into numbers. But generally, for my own sake, I prefer to do things in Excel because I find it just easier. So how do you code it? How do you know if strongly agree is a 5 or a 7 or a 9 or, totally true of me is a 4 or a 10, or what are those things coded for? So first of all, use precedence, meaning most of these things have already been done before. If you're using a scale, somebody else probably created it. How did they code the scale? Use that coding. In fact, there's strong reasons to use that coding because then the scale scores from then on will mean the same as all other articles that have used that scale. So you want to use the coding that is based on precedence as your first step. However, sometimes there is no precedence. Sometimes you're coding something and there's no code anywhere, or it's a brand new scale you created or something. Then you just use logical numbering. Typically, if you're measuring a construct, you want a higher number to indicate more of that construct. So if you're measuring something like depression and everything's on a scale of 1 to 5, then a 5 would indicate that the person is more depressed and a 1 would indicate that they're less depressed or something like that. So something logical like that. You might code missing data that comes in as a 999. You might leave it blank. It's kind of up to you. There are ups and downs to that. And then you'll want to create a key for your records. So as you're going through coding things, you'll want to write down on a piece of paper or in a Word file somewhere that, 5 equals strongly agree and 4 equals agree and 3 equals neutral or whatever it is that you're coding for the different things. You'd be surprised how much you can forget as you move along through the process. You'll see here a coding within SPSS, this picture that I have. And there's something called values within the value labels. And you can click on that. You see next to the law in yellow, there's like a triple dots there. You can click on that and it opens up this window called value labels. And you can go in and say, okay, I want 1 to be law and 2 to be economy and 3 to be social sciences or whatever. So especially if you have things that are not total scale scores, but they are demographics, things like gender and job satisfaction or education or things like that you want to code. Coding that within SPSS will make all your output from then on will come out with law as the output instead of just the number 1. And the number 1, you'll have to go back to your code book every single time and go, what was a 1 again? I don't remember. Was 1 law or was 1 social sciences, right? And you can make more mistakes. So it is good within SPSS to also go through a process of putting in codes for things that are relevant. If you have a total scale score of a depression scale, you probably don't want to code it because each individual answer doesn't need a code. But if you have something that's not obvious like this and you're creating a code for categories, that sort of thing, I recommend doing that kind of code as well. The next step for cleaning up data is to get it into SPSS or whatever data analysis program you're going to be using. Importing from Excel is quite easy. You can actually see some screenshots here on the right where you just go in and tell it to open data and then you go down to Excel and tell it you want to open that and it moves through a little guidance for you. It does do other formats. So make sure, however, when you are creating your overall plan for your research, that whatever you put your data into prior to SPSS or similar program, that it can convert easily. So I know Excel converts easily. Other things, you'll want to make sure they can convert easily. You can actually also set up in SPSS so that the first row of your data is the label. So it will automatically turn that into your SPSS label, making it easier. One thing to note that I've seen, if you're using some programs like SurveyMonkey, it will actually do 2 rows that are labels, and then SPSS can't handle that. So you actually have to go through by hand and turn those 2 rows into a single row. And you'll see more about that when you have your own data, but just to let you know. And this is a simple task. You can Google this. on the internet when you need help on it. And many other things in SPSS and data management can be Googled, and you can get some help on, step by step with screenshots on how to do it. Now that you have your data in SPSS, you'll want to run frequencies in SPSS. So you click on Analyze and Frequencies, and within that, it will give you the frequencies for all of your data. So put all your data over, put it all over in the right-hand column and tell it run all of it. And then just go through every single one looking for things that are impossible. So for instance, if you have a question that was coded 1 to 5, maybe, from strongly disagree to strongly agree or something like that, and you see the number 55 show up on that question, you know that there was an error in data entry. And so you'll want to go in and fix that. Or if you check people's age and you realize somebody reported that they're 125 years old, that they were born 125 years ago, that is highly unlikely unless you have a very unusual database. So you'll want to probably go back and fix that. So there can be obvious errors, obvious outliers, and you'll want to look for those because they're typically mistakes. If your error can be backtracked to the original raw data to look and see, then that's a good thing to do. If you have things like people saying they're 125 years old or they're answering in ways that seem impossible, you might want to look at that particular person or case across all their data. Sometimes you'll find that you have someone who was messing with you, basically. Like they were not answering in a valid way, and you might have reason to just go ahead and remove that case from your data set. So using original data is one way to do things, or just deleting the data. If they say they're 125 years old, but everything else seems right, you can assume, well, they probably have some kind of, data entry error that happened, and I can't undo that. I can't look up their actual age, so I'm going to just delete that point of data from my data set because it's obviously an error. Once you've gotten rid of all of your obvious errors, then it's time to go through and code or recode your data. So most of the time when you have scales, measures, some kind of total scale score that has to be added up to get you have kind of add up or formula to get that score. But most scales also have items within them or questions that are reverse coded. So for instance, say you have a depression scale and it has one item that says, I feel happy most of the time. But all the other items are things like, I feel blue, I feel overwhelmed, I hate my life, whatever. That one item is obviously reverse coded. And so now what you need to have happen is strongly agree needs to become the same as a strongly disagree for the other items. If there's a recode, most scales that you get will tell you which items get recoded, and you can use that. Every once in a while I have found some don't tell you. You're just you have to figure it out yourself by looking at the actual questions that some things are recoded. But in this case, if it's a 5-point scale, for instance, from strongly disagree to strongly agree, you'll want to tell the computer and recode, well, my 1, for these questions, my 1 is a 5 and my 5 is a 1. My 2 is now a 4 and my 4 is now a 2, and I want to leave the 3 as a 3 still, right? And so you'll have different things for different codings. If it's a 6-point scale or a 7-point scale, that will change it obviously, but you'll want to go through and code those. You'll then want, and you can see here a picture I have from SPSS that there is an option to transform to recode. You can recode into a different variable, meaning it will create a new column for the new variable and leave the old uncoded, non-recoded item behind. Or you can recode it into the same variable. It's kind of up to you about that. But just make sure you log it, label things clearly. For instance, when I'm doing this, because it's always possible I'm going to get distracted in the middle of recoding 20 different questions or something. And then I'll be like, oh no, did I already recode that question or not? Oh no, now I have to go back to the raw data and try to figure it out. And that is a mistake I have made. And so learn from my mistakes. And so what I do is when I recode it, I go and I change the label and I put an R dot and then whatever the name of the item was before. That way I know that particular column has already been recoded, and it's already been done, and I don't need to do it again and unrecode it um, and flip it back. So, okay. The next step is to replace missing items with case-wise mean scores. So this is just really for scales. So if you have missing, as you see in the picture here, education, which is a single question, and you're missing education, you can't really get a case-wise mean score for that, right? Unless you had a bunch of questions on education. I don't know how you would possibly do that. But something like demographics, you're just stuck. You can't replace a missing item with a case-wise mean score there. However, if you have a depression scale and you had 10 questions on a depression scale and they skipped one of the questions, you can replace that one question with that particular person, that case mean score, right? And that is the best way to handle that. But you should only do this if you're missing some items. So like, for instance, say there's a 10-item questionnaire on depression and someone skipped six out of the 10 items. They only answered 4 of the questions. I would just go ahead and delete that person's depression score, and you can just leave it because it won't add it up. But the reason you need to replace missing items in SPSS is if you do need to add up scores, which is going to be next, if a single item is not answered, it will not add up that particular person for anything. And for most students, your work has been extensive to collect this data, and if you have one question missing, you don't want to throw the entire case out because of that. And there's no reason to really, on a logical reason. So for each case, which is a row in SPSS, you want to find the mean score for that particular scale. Now remember, not the entire, you don't want to add up every question they answered. That doesn't mean anything. But if they have a scale or a subscale, you'll want to go in and add up what was that person's mean score for the 9 questions out of 10 that they did answer. Maybe they have a mean score of 3.45. Great. Okay. So take the missing one, right, and type in 3.45, right, and hand enter that and replace the missing with 3.45. And so you can see then you don't actually change their score, right? You keep it the same as the questions that they actually did answer. Be judicious about doing variable-wise mean replacement. So things like education that you see there, you can replace that with the mean education for the entire sample. And if you're doing that for 1 or 2 cases in a data set, that's probably fine. However, if you do that with a large number of cases, then it becomes a big problem. You actually make your data leptokurtic, so you want to make sure it's necessary, and that you're not replacing too many cases. And sometimes you don't need it. So for instance, if education is not a predictor variable, it's not an independent variable or a dependent variable in any of your things, it's just descriptive data, then you don't need it to be replaced. You can just report, of the 100 people, 99 answered, and their average education was this, right? Because you're just reporting the sample, and it's fine if there's some missing data in some of that. Whatever you do with all of this, make sure you do log what it is that you did, right? And in a dissertation in particular, it's often required that you report how much data was missing, what you did with your missing data, that sort of thing. So you would need to say like 7 cases were missing less than 10% of their answers on the forgiveness scale, and I replaced it with case-wise mean scores, right? And so you need to have that specific level of reporting. I have a little trick I do for this, because once you replace the mean score and hand enter in their answer, you really can't know from then on, from the data set itself, from the SPSS data, which ones were originally missing and which ones were the original true data. So I use decimals to track. So for instance, if something is scaled 1 to 5 and I'm going to replace a missing spot there with 4.25. Well, it's got decimals already, so I'm going to know, hey, it's a 4.25, so that was obviously a originally missing data, because no one could actually answer 4.25. If, for instance, my data pops up and it's a 4.0, right, then what I will do is I will hand enter 4.001, right, or 4.0001, or something like that, that lets me know originally this was missing. So if for some reason I lose my log, or for any reason in the future I ever need to know where the missing data was, where it came from, then I have these decimals in there and they can show me. If your data comes in decimals, as you can see from like the W hours example here, then you might need to do something else, like I don't know, 2.51 2.510001 or something like that, which wouldn't affect your data at all to have that number, but it would let you know that you have entered, something that was missing, that this originally was missing data. For most data sets, the end goal is to get some total scale scores. So you're going to be wanting to capture and total up, forgiveness or depression score, or the PCL for a trauma measure, or whatever that you've measured that's a, multi-item Likert scale questionnaire or something like that. And so you'll need to create your total scale scores. So finally, we are at that point in the process. And what you want to do here is go back to the directions from the article or whatever source that you got the total scale score, and it will tell you. Often you're just adding up the questions, which SPSS can do that for you, and you just add up question 1 plus 2 plus 3 plus 4 plus 5. Occasionally there'll be subscales and you need to go, okay, I need to add question 1, 4, 7, 8, 12, 14, and 22, like something like that. So make sure that you're careful here. One mistake that sometimes happens is that make sure that the way you numbered your questions is exactly the same as the way that the original article or scale ordered them, numbered them. Once in a while, from the process of taking it from there and putting it into your online questionnaire or your paper questionnaire that you gave to people, to coding it, throughout that whole process, things can sometimes get swapped around and moved. So you'll probably want to do a double check here and just make sure that question 1 was, I feel very blue, right? Yes, that's my question 1 too. Great. Okay. And so just kind of double check that. You're almost done now. Your final steps here are to check your total scale scores. So remember this total scale scores that you just added up and got your total numbers, your total depression or your total trauma score, or your total, academic score or whatever. That is new data. You have not checked that yet. So make sure that if it has errors, if it has impossible numbers, in particular, if you had to do any kind of like formula where it was like we had to add these 4 and multiply it by 5 and then divide by 7 or do anything like that, you might want to check and make sure that that happened correctly, that what you did in SPSS to total scale that up is what you intended to happen. Maybe check a couple check a couple cases and hand score them, make sure that they did that. I've on occasion found impossible numbers, meaning like the scale should run from 10 to 50, but I've got a few 7s in there, or there's several 52s. That means something went wrong. And so you'll want to go back and check and see, what went wrong? Why do I have a 52 when the maximum score that someone should be able to get on this scale is a 50? And so you can find some errors there. Sometimes there are obvious outliers, and so you'll want to look at that. Sometimes the obvious outliers are mistakes, like the 52 when the maximum could be 50. Or you could start looking for outliers here on a univariate level. So in statistics class that I teach, we cover different ways to kind of decide whether something's a univariate outlier. And so you might go ahead and look at that on your scale scores here. You might want to go ahead and check your skewness or your skewness and kurtosis and just kind of get familiar with it and kind of know like, oh, shoot, It's skewed. I'm going to probably have to transform this. So this is a great way to get to know your data and get it ready for the next step, which is checking all of your assumptions. And for this final slide, I have seen mistakes in this process. It is pretty detailed, as you can tell. It requires some OCD, and some people are really good at OCD level of data management, and some people are easily distracted or perhaps not as motivated or just not as gifted at it. And that's just, we all have different brains and different ways of managing bits of information and different backgrounds too. Some people have been trained in kind of research laboratory procedures and being very precise and exact and detail oriented, and other people are not as strong in that. And so it is very important to log everything you do throughout this entire process of getting your data ready for analysis. Mistakes within this process are probably more common than not. Like, the hope is that any mistakes you made are not going to affect the actual outcome. Maybe, one case here or there, or one point of data out of thousands of points of data that you made a mistake on. But systematic errors where you totaled something incorrectly, or you reverse scored something wrong, or you didn't code it correctly, things like that can really create fairly random data, and then you can end up never finding anything significant if your data has been randomized. So I strongly recommend, because of this, each step along this way, along these 8 steps, save a new version of your file in Excel and then SPSS. So put a date on it, or even a nice long description. I have often done things like data for cool study, January 10th, 2022, after I've recoded it all, right? And SPSS and other programs can handle that long of a title, and it's fine. And it will let me know, okay, that's where I left off. Because you always have this moment, too, where you intend to come back to your data tomorrow and finish it up, and then all of a sudden things happen in life, and it's a month before you get back to it, and you can't remember where you left off. And now you have to start back at the very beginning yet again with your raw data, and you might have lost a day of work because of that. So log everything, which will help you, and then save new versions all along the way. Also, if you make a mistake and realize that, you can go back to the previous version instead of having to go back to the very beginning of the journey. You don't want to have to go back to the Shire on your way to Mordor. And then at the end, go back to your very raw data. This is just a word of wisdom. Pick 5 people at random in your study, their raw data, and hand manage them. Essentially, go back and double check that the data that you have in your very final data set is the same data as what you have in your raw data. Just kind of like go across and look at it. Make sure that nothing's happened to them. Every once in a blue moon, data gets completely randomized. Particularly watch for that in Excel. Excel can randomize your data in ways that will make you cry. And I'm not saying I've cried over that before, but I probably have. And then, so this is a great way to just triple check that what you were looking at in your final data that you're getting ready to analyze is actually accurate. It's not been confused, it's not been randomly sorted, and all the ID numbers, thrown out the window, or all their total scale scores incorrect, that kind of thing. So that's my tips for having great data that you can rely on, that you can then find in the end. I'll give one motivational note too, and that is mistakes in this, what they will do is they will create more random error in your data. And the more error you have in your data, the less chance you're going to find anything in your final analysis. So once in a while, too, when I've had students and they're running their analysis and it's like, man, this really should have come up with something, right? Like, at any time you can have a data set that doesn't support your hypothesis, but we're really surprised. Like, this isn't the first time this has been studied, or this is something we pretty much always find, and it didn't work out in their data. Then we'll go back through this whole process and kind of check it all along the way, and sometimes find that there was a mistake somewhere in here that created error in the actual data set. And if you don't have good records and a good log and 10 different versions of it all along the way that you saved, then you can't find those mistakes. And it's just a shame to do 2 years of work and then you had significant results, but you can't find them because your data check wasn't done well. So, all right, good luck.